Okay, this is practice 6B on electron dot notation and paying attention to how many valence electrons an atom has. Remember, we're using this new system of numbering on the periodic table where if you can make these modifications, this new numbering system will tell you how many valence electrons are in elements that are in group 1, how many valence electrons are in group 2, how many valence electrons are in group 3, and it all has to do with this thing that we tried in chapter 4 or 5 called ending electron configuration. You saw that in lab 5A, you saw that in lab 4B, and you even heard that term, ending electron configuration, outermost electrons, in the chapter 4 review. So none of this is a mystery. Here we go. Number 1A, phosphorus has already been done for you. You know that phosphorus has an electron configuration that ends 3s2, 3p3. You know that because phosphorus is in this new group, group 5. It ends s2p3, and it happens to be in row 3. That's how we put that together. Anyway, let's try this next one out. It's asking how many valence electrons or outermost electron configuration is in tin. Tin is a weird element. It's got the symbol SN, and it is in here, row 5. It has an electron configuration that ends s2p2, like carbon and silicon and germanium. So we're going to say, because it's in row 5 and it ends s2p2, it is 5s2, 5p2. That adds up to 4 electrons. Here is strontium, right here. Oh, so close. Isn't that nice and convenient? Strontium is in group 2. Its electron configuration ends s2, and it happens to be in row 5. So we're going to say it's got an electron configuration that ends 5s2. That means it has 2 electrons. Finally, antimony is one of those weird ones with a weird symbol, Sb. Oh man, right next to tin. That means it's in row 5, and it ends s2p3. Well, s2p3 means it's got a total of, count them up, 5 valence electrons. That's why we named this new group 5. So it's in row 5. Its electron configuration is 5s2, 5p3, which means it has a total of 5 electrons. Just like phosphorus, huh? Phosphorus also happens to be in that same group, and would you look at that, in the same one as antimony. There's our buddy phosphorus. Nice connection. All right, let's cut out the middleman. What is the electron dot notation? How many valence electrons does each of these atoms have? Here is calcium in row 2. That means it has 2 valence electrons. There are some of you that like to keep them nice and neat. We'll put them up at the top. That's great. If others of you want to put one on one side and one on the other, that's fine too, just as long as there's 2 of them. We find gallium here in this column that we have now marked with a number 3. That means gallium has got 3 valence electrons. Put them wherever you want. 1, 2, 3. Or you can say 1, 2, 3, doesn't matter. Last one, germanium. We see germanium here. Germanium is in the same column that carbon is in. They have 4 valence electrons. Some of you like to put them 1, 2, 3, 4, and I'm cool with that. Or if you want to put 1, 2, 3, 4, that's up to you. Keep the ball rolling. Here is arsenic with 5 electrons because it's in column 5. Let's look up selenium. We'll see selenium is right here. Selenium is in the same column as oxygen and sulfur. It has 6 electrons. Where are we going to put them? I'm going to write selenium's atomic symbol, and it has 1, 2, 3, 4, 5, 6, or you want to keep them in order, as some of you like to do. Perfectly fine. 6 valence electrons. Here's bromine. We find bromine in this column. It has 7 electrons. That's why we have renamed it 7. And so we'll say bromine has 1, 2, 3, 4, 5, 6, 7. You want to keep them in order and say 1, 2, 3, 4, 5, 6, 7. That works fine too. Last one, krypton. Krypton is a noble gas. We find krypton in this new column that is now column 8. That means it has 8 electrons in the valence. I'm just going to fill up all the sides of this krypton so that it has 8 valence electrons. Okay, we're getting the hang of this. Here is aluminum. Where do we see aluminum? It is in this column on our periodic table. Column that is now marked column 3. It means aluminum has 1, 2, 3, or if you want to write them, 1, 2, 3 valence electrons. That works too. Oxygen is in this new group 6. We see oxygen right here. Oxygen is in this new group that is marked with a 6. That means that oxygen has got 1, 2, 3, 4, 5, 6 valence electrons, or if you want to keep them in order, 1, 2, 3, 4, 5, 6. That works too. Last one on this page is iodine. Iodine has got, according to this table, it is now in group 7. That means it has 7 valence electrons. We're going to say that because it has 7, you can put them wherever you want. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. All right, let's go to the back page. What this is telling you is for each of the following elements, please indicate the number of electrons in its highest energy level. Ladies and gentlemen, that's this. S1, S2, S2P1, S2P2. That is the number of electrons in the highest energy level. That's what we're using to indicate the number of electrons in the valence. So we've done fluorine because it has S2P5. That means it's got 7 electrons, and you see them here. Let's do that for all of these. And I'm going to go pretty quick because now you know where to find these on the periodic table, so I'm not going to keep showing you. Magnesium is in row 2 and it ends S2, so it has 2 valence electrons. Aluminum also in row 2, it ends 2s2, 2p1. I'll show you where I'm getting that just one more time. You'll see it here. Aluminum is in. I apologize. Aluminum's in row 3, not row 2. See, even the pros make mistakes. We're not really interested in what row it's in. We are interested in the fact that it has 3s2, 3p1. We're interested in the fact that it has 1, 2, 3 valence electrons. That's all we're interested in. Here is phosphorus, also in row 3. It is in the same column as nitrogen, 3s2, 3p3. It has 1, 2, 3, 4, 5 valence electrons. Put them wherever you want. Argon is a noble gas. Argon is in row 3, and because it is a noble gas, it ends S2P6. It has a grand total of 8 electrons in the valence. All right, we got the rhythm now. Here is sulfur. Sulfur is in the same column as oxygen. It is in row 3. It ends S2P4, so it has 1, 2, 3, 4, 5, 6 electrons in the valence. Germanium, I can't remember where that one's at. I know it's in the same column as carbon and silicon. There it is. It's in row 4, and it ends S2P2. That means germanium is 4s2, 4p2. That means 1, 2, 3, 4 electrons in the valence. We know calcium is in row 4, and it's in the second column, which means it ends S2. That means it has 2 electrons in the valence. Carbon Same column as germanium. It ends 2s2, 2p2. That means it has 1, 2, 3, 4 electrons in the valence. If you want to keep them in order, nice and tidy, you can do it like that. Okay, last 3 and we're almost done. Boron, right next to carbon. Right next to carbon, right here. Right next to carbon. Carbon ends s2p2. That means boron's going to end s2p1. That means it's got 3 electrons in the valence. So it's in the second row, s2p1. It's going to have 1, 2, 3 electrons in the valence. We're almost there. Nitrogen in the same group as phosphorus, now group 5. It is 2s2, 2p3, 1, 2, 3, 4, 5. Here is xenon, a noble gas. We know noble gases are in all the columns that end s2p6, and xenon happens to be in row 4. So 1, 2, 3, 4, 5, 6, 7, 8. And the last one, indium. I believe indium is in the same column as aluminum, but I can't remember. So here is, there it is, indium. It's in the same column as aluminum, boron, gallium. It is in row 5. That means it's got an electron configuration that's going to end 5s2, 5p1. And that means it looks like this, indium. It has an electron configuration 5s2, 5p1. It means it's got 1, 2, 3 electrons in the valence. That took me 11.5 minutes, and it shouldn't take you much longer than that. All right, see you on the next one.